So what is the nth term? Indeed, what is the nth term formula? And that for the arithmetic progression, which is AP. Now let's say we have actually an AP series given us a 3, a 5, 7, should be 9, 11, let's say 13, and assume that the values are keep on going this way. So now, what is the value on position 2? So now the value on the position 2 is given as a second, should be the second term, and which is given as should be given as the second term. So what is the second term? We'll have it as a 5. So this 2 represents that the value is on the position 2. It also represents that reaching up to the position 2, we have 2 number of terms, which is now actually 5 as the second term. Now how about, let's say, the fourth term? How about the fourth term? The fourth term is the value which is on the position 4, and for this actually typical AP actually a series. So what is the value on the position 4? Have it as 1, 2, 3, 4, and which is 9. So which means, and for us to get reached to actually where the 9 is, it means we should have to count about the 4 terms or so, which means in that particular set of the actually series values, it means we are having 4 terms for us to reach up to where 9 is. So what is the nth term? Nth term is the last actually a term. That is the last term that is said to be the actually nth term, and it is symbolized as nth term. Now for this case, how can you be able to have, let's say, the term on position 6? In this case, the 16th term, we'll have it as 1, 2, 3, 4, 5, 6. We have it as 13. So which means 6 is the number of terms or the position in which the term is. And how about the term, let's say, on position 20? We'll have it as the 20th term. So in this case, of course, you may think of having proceeding the series, you may think of having, let's say, 15 until you have reached the position 20, but it is a tarsum. So what is the best way can be able to have the last term and for the arithmetic progression? So now we use what you call nth term formula for us to have the actually a last term. So nth term is the same as the last term. Nth term formula is the formula that helps us to have the last term, and actually for the arithmetics, for the arithmetic series. And for instance, let's say if we have the first term given as A, and for the arithmetic progression, this is the first term, and we have the common difference given as D, and let's say the number of terms is given as N. So what is the formula that can help us to have the last term of an arithmetic progression? So the formula is said to be the nth term formula, which is given as nth term is equal to the first term plus n minus 1 times d, where this is the first term, this is the common difference, and this is the number of values, actually number of terms, where actually 1 is a constant. So which means if we have the first term and if we have the number of terms or the position, we can be able to have the value on that position using this formula. And for instance, for the actually a series that we have here, what is, let's say, 15th term? That is the term on position 50. So what is that one? So in this case, you have to understand that as it stands here, it means the number of terms is given as 50. And we have the first term, which is given as should be 3. And we have the common difference, which is 5 minus 3, and which is equal to 2. So what is the 15th term if that's the case? So now 15th term we'll have it as now a 3 plus a number of terms which is 50 minus 1 times the common difference which is 2. So now which means we can have it as let's say a 15th term will be given as 3 plus, so now have 49 times 2. So what is 49 times 2? So 49 times 2 is given as the 98. So have 3 plus 98. So what is 3 plus 98 if that's the case? So have it as 101. So which means only actually for this particular a city, the value on the position 50 is that of should be 101. So that is the principle behind. So we only get the last actual term if we have the first term as well as the common difference. That's the easiest way to. Now let's say we have this typical arithmetic progression. So let's say have -2, -5, let's say negative, it should be 7. So in this case, what is the actually should be 215th term, and for this particular arithmetic progression city. So as it stands here, it means the number of terms should be given as that of 250, because it shows the position in which the value has to be at. So starting from the actually 1 up to 100, actually 250 as the number of terms. So what is the first term? We have it as -2. And what is the common difference? We have it as -5 minus -2. Now which is equal to, we'll have it as -3. That is the common difference. Then what is the 215th term if that's the case? So now which means we can have it as 215th term. We'll have it as a, which is -1, should be a -2 plus now 250 minus 1 times the common difference, which is -3. So you'll be able to have that amount in that way. So now what if this is the case? Let's say we have a certain arithmetic progression city with the first term given as, let's say, half, and the common difference is given as 5. So what is the 20th term if that's the case? What is 20th term if that's the case? So in this case, it means the number of terms is given as 20. Now since we have the first term and the common difference, we can be able to have the term on the position 20, which is given as 20th term is equal to the first term, which is -half, that plus n minus, now n means should be 20, minus 1 times the common difference, which is given as 5. So now which means we'll have it as -half. So that is, we have it as -half. So what's that? Let's say -half and plus actually 19 times 5. So we have 19 times 5, which is 95. So have it as should be 95. So what is -half plus 95? So what is -half plus 95? So have it as 94.5. So which is given as the 94.5. So should be 94.5. So this is actually a 20th term. And how about if we have this case? Let's say we have in this particular set, let's say we have a 2m, let's say minus 5m plus 2, and say we have, let's say, a 6m minus 5. Let's say the values are keep on going up to the, let's say, infinity. So now if this is the case, what is the, let's say, should be 35th term, and for this particular accuracy. So now according to the given information, it means the number of terms is given as actually 35. That is the essence behind. So which means the number of terms is given as 35. But now we should have to express what is the value of m first before we get up to having 30 actually 15th term. So according to the principle behind that, we discussed it before. So in case you missed the lesson, in case you missed the lesson, just have to refer to the way we discussed about how you can be able to deduce the nth term formula, and you'll be able to come across this kind of a problem. So just have to refer to that one. So how should you be able to have the value of m if this is the case? So much as this is the arithmetic progression, it means at this point the common should actually, at this point the common difference is the same at this point. So if that's the case, then we'll have negative 5m plus 2 minus 2m, that which is equal to 6m minus 5 in the minus 5m plus 2. That is the principle behind. So now which means we'll have negative 7m plus 2, now which is equal to, we'll have 6m minus 5. We'll have to distribute this negative in the sense that we can have it as, by the way, we have a minus here, so it means minus times 5m, and I will have it as a positive a 5m in the minus 2m. So it should be minus 2, rather should be minus 2. So now we'll have to have the like terms, have negative 5m plus 2, which is equal to that which is 11m in the minus 7. So take note of that. So in this case we'll have it as negative 7m in the minus 11m, which is equal to negative 7 and the minus 2. So have it as negative 18m, and which is equal to, should be a negative 9. So now which means we'll have m being given as negative 9 over negative 18, which is the same as 1 over 2. So that is the value of actually m. You should have to know. So that is the value of m. So now we have the value of m, which is given as, and that should be half. So what is the first term in the common difference? So now the first term actually, which is given as a, is equal to 2 times half, that which is equal to 1. That's the first term. And what is the common difference? We'll have it as this one minus this one. That's the common difference. So we'll have negative 5m plus 2 minus 2m, and of which we'll have negative 5 times half, and should be plus 2 minus, we have here as 1, since we already have it as this one. So now which means we'll have it as negative 5 over 2 plus 2 minus 1, of which we'll have that one as 1. So now which means we'll have it as the common difference now being given as, we'll have it as negative 5 over 2 and plus 1. Of course we'll have it as negative 5 over 2. So let me just have it in a decimal form. Of course you may have it as a fraction, but let me just have it in decimal form. So with the calculator we'll have the common difference, that is now negative 5. So it should be negative 5 and divided by, should be 2, and plus 1. That is, now we have the common difference that will be given as negative 1.5. Negative 1.5. So that is the first term as well as the common difference. So what we need is the 35th term, of which we'll have the 35th term, which will be given as the first term, which is given as 1 plus the number of terms 35 minus 1 times the common difference, which is negative 1 over actually 0.5. You'll be able to have that and out in that way. So take note of that. And what if we have this case? Now let's say we have it as, let's say, 2y minus 5 and comma 5y plus resetting, let's say have y minus, okay, negative y minus 2. Let's say the values are keep on going. So what is the 10th term? And also let's say what is 12th term? And also what is, let's say, 102 and the second term? Let's say that's the case. So try to have it in the same way that we have discussed it here. So you'll be able to have that and out. So bear that in mind. So what is the thumb of rule? What is the thumb of rule for the actually nth terms? Now we can be able to have the formula for the nth term, and that is if we have the first term as well as the common difference, and if the number of terms actually is known. So let's say we'd like to have the nth term for the actually first value. So now for the first value, that is for the first value. What is the nth term for the first value? So now for the first value means the number of terms is given as 1. And we don't know the first term as well as the common difference. But what would be the nth term formula for the first value? We'll have it as the first value. A term will be equal to the first term plus 1 minus 1 times the common difference. That will be given as A. That is the nth term formula for the first value. No wonder the first term is symbolized as A, because on the first term it means the number of terms is 1. We'll have here as that will correspond to have the first term being given as A. And how about if we have to look for the nth term for the second actually term? What is that one? What is the formula for for the nth term for the second value? For the second term. So have a second term. Now it should be this. Let me just have to completely erase this one out. Now for the second term, which means we'll have it as first term plus, now number of terms will be 2 minus 1 times the common difference. That will be given as A plus should be D. So this is the formula for the second term in our arithmetic progression. So that is the formula, where the number of terms is known and the first term as well as the common difference are unknown. And now how about the third term? What is that one? So which means we'll have n given as 3. So have the first term 3 minus 1 times t. That will be given as A plus 2d. And how about the fourth term? We'll have it as A plus 4 minus 1 times t. Now that will be given as A plus 3d. Now there is a trend you should have to understand about. Now you can see that the first term is given as A. The formula for the second term is given as A plus d. And the third term is given as A plus 2d. And the fourth one is given as A plus 3d. So which means there is increase in a common difference by a factor of 1. So in this case, even 20th term we'll have it as A plus 19d. Let's say 15th term we'll have it as A plus 49d. How about, let's say, 40th term we'll have it as A plus should be 39d. So should be 39d. We'll have that as that. And likewise, let's say nth term, let's say nth term we'll have it as a plus 7d. Let's say 18th term, we'll have it as, should be a plus 17d. So please, you should have to familiarize yourselves in these actually formulas. So that is, let's have to appreciate this question. Now, given that, let's say the 10th term of an AB, let's say is given as, let's say 50, and also given that, let's say the 4th term is given as, let's say 8. So what is the first term common difference as well as the nth term formula, if that's the case? And we're given that for a certain arithmetic progression, a 10th term is given as 50, 4th term is given as 8. What is the first term common difference as well as the nth term formula for that particular actual case? So what is that one? So what is the formula for the actually 10th term? So formula for the 10th term is given as a plus 9d. What is the 10th term? We'll have it as a 50. So have 50 is equal to a plus 9d. This is said to be equation 1 because first term as well as the common difference are known. And what is the actual formula for the 4th term? So 4th term is given as a plus 3d. Now of which we have it as 8 is equal to a plus 3d, that which is equation 2. So now we have two equations with common unknowns. We'll be able to have to solve for a and b using, actually that is simultaneously. Now let's think of using elimination method. Of course we have several ways. Actually we have, should be substitution method, we have elimination method as well as the graph method. So whichever way, but I'd like to use the actually elimination method for this case. So let's use the elimination method and for actually this case. So how should we be able to have the first term as well as the common difference in that way? So let's use the elimination method. So now as you can see, we have the single a's in both equations. So we'll have to multiply this one by 1 and also this one by 1, of which we'll have it as 50 is equal to a plus 90. We have 8 is equal to a plus 3d, of which we'll have to subtract the equations to get rid of a. That is according to the elimination method. So we'll have to subtract the two equations. We'll have it as 42, that is 50 minus 8, we'll have it as 42 is equal to, now this is cell, then we'll have 9d minus 3d, which is now a 60. So which means we'll have the common difference being given as 42 divided by 6. What is that one? 42 divided by 6. And I will have it as 7. So which means the common difference is given as 7. And how about the first term? So now the first term is given, let's say we should have to substitute in the equation number 1, which is given as 50 is equal to a plus 9 times 7. We'll have 50 is equal to, what is 9 times 7? 9 times 7 is given as 63. So have a plus 63. And of which you have the first term being given as 50 minus 63. That will be given as, so what is that one? We have negative 13. That is 63. That is 50 minus And that should be what? 50 minus 63. We'll have it as a negative 13. So which means the first term is giving us the negative 13. So now we have the first term, the common difference. How can we be able to have the actually nth term formula if that's the case? What is the nth term formula for that particular case? So now, since we have the common difference given us 7, the first term is given as negative 13. So what is the formula for the nth term? Nth term formula is given as a plus n minus 1 times t, of which we have the first term given as negative 13 plus n minus 1. The common difference is given as 7. So which means we'll have negative 13 and plus 7n and minus 7, which is the same as, so now we'll have it as negative 20 plus 7n. So this is the actually nth term formula, you should have to understand. So that is now the nth term formula. So now what is, let's say 13th term, the term on position 30. So which means in this case the n is given as, so which means the n is given as 30. So we just have to substitute for n into the nth term formula to have the value on the position 30. Likewise, let's say on whichever the position will be able to have that out. Let's say what are the, let's say the first 5 times, so which means for the first term we'll have n is equal to 1, or substitute. In the second term we'll have n is equal to 2, or substitute. The third, and as well as the fourth and 15th, you'll be able to have that out in that way. So take note of that. Now what if we have this kind of a problem? Let's say we are told that the 7th term of an arithmetic progression is equal to 2 times, let's say, a third term. Let's say is equal to 2 times the third term. And given that the first term, and also given that, let's say, the 10th term is 1/3, let's say, is said to be a 1/3 of, let's say, 15th term. Let's say said to be 1/3 of 15th term. 1/3 actually it means the term number 15 divided by 3. So what is the first term? What is the common difference? And what is the nth term formula? And what is, let's say, the first 7 terms if this is the case? So how should we be able to have that an up to? So now let's start interpreting this. What is actually a 7th term? So now the formula for the 7th term is given as a plus a 6d, and which is equal to 2 times the third term. What is the third term? We'll have it as a plus 2d, and we'll have a plus 6d, which is equal to 2a, and plus 4d, and of which you'll have it as, upon having that terms, we'll have a minus 2d, actually a minus 2a plus 6d minus 4d, which is equal to 0. So have negative a and plus 2d, which is equal to 0. That is the first equation. Then I should have to interpret the another expression, which says that the 10th term is equal to the 1/3 of the 15th term. So what is the formula for the 10th term? We'll have it as a plus 90, which is equal to, what is the 15th term, we'll have it as a plus a 14d divided by 3. So in this case, we'll have to express that one. Let's say we should have the cross multiplication. We'll have a plus a 14d, that which is equal to 3a plus 27d. So have another equation here as equation 2. You solve this using the simultaneously, and everything will actually be in the same way we have discussed it recently. So bear that in mind. And also try this problem as well to have to understand up to. Let's say we are told that the third term should be the third term of an arithmetic progression is, let's say, a 3/4 of let's say it's a 3/4 19th term. So what is 3/4? It means 3/4. 19th should be 19th term. Should be 3/4 19th term. And we are sure that the second term is, let's say, 2 times, should be, the second term is, let's say, 1/2, let's say is 1/2 a 4th term. So what is the first term, the common difference, and also the nth term formula? That should be the nth term formula if that's the case. You also try that one out at your own time to have the solution. And also, what if you have this case? Let's say the difference between the 7th term and let's say the 4th term is equal to 3 times, let's say, the 10th term. Let's say this is the case. So it should be that. Sorry for my poor handwriting, but I understand you get it right. And we are sure that the 4th term is, let's say, 5 times, should be the second term. So it should be 5 times the second term. What is the first term common difference as well as the nth term formula for this particular arithmetic progression series? So now try to have that and out at your own time. By the way, we have 3 times the 10th term. Now the 4th term is 5 times the second term. The difference between this, actually, the 7th term and the 4th term, so should be that. So try to have the solution of this problem as well. Thank you.